Hello and welcome to our podcast on reaction rate laws, which is sections 3 in chapter 17. Uh, what is a rate law? A rate law basically is a way to quantify the collision theory, and basically it's a mathematical equation that expresses the relationship between the rate of the reaction and concentration of reactants. Now there are many ways that the concentration will have an effect on how fast the rate goes, and this is something that's expressed in the rate law. For instance, if we have theoretical reaction, reactant A becoming product B, the rate law would be a constant K times the molarity of A. Okay, and this would be one way to express it. To talk a little bit about K is what we call the specific rate constant, and it's basically a value that relates the rate of the reaction to concentration at a given temperature. The units of K will actually vary depending upon the rate law, and we'll get into that a little bit more in a moment. It does need to be determined experimentally. You can't just look at a reaction and know what K is. It has to actually be measured, especially since it's temperature dependent. And because it's dependent upon temperature, the value of K will change with respect to temperature. Reaction order. This is also part of our rate law, and this basically defines how the rate is affected by the concentration of the reactant. Now there are different kinds of order to be aware of. Okay, in the one I showed in the previous slide, the rate was equal to K times A. Okay, so that represents what we call a first order reaction. So this is a situation where the rate is directly proportional to the concentration. So if the concentration doubles, the rate of the reaction doubles. Now there are other orders of reaction to kind of keep in mind. For instance, in zero order, the rate law would look like this. So the rate equals K times A. We're using our same reaction from before, to the 0 power. If we have something to the 0 power, we know that just equals 1. That means that the rate would just equal K. For zero order reactions, it doesn't matter what the concentration is because the rate will just be whatever K is. Now this is different than first order. I didn't write the 1, but this is really to the first power, which basically means that the rate is directly proportional to not only the value of K, but also to the concentration. We can also have second order reaction orders, and this would be an example where the rate would be equal to K A to the second power. So that equals the rate, and this second power just basically means that the rate will be the square of whatever the concentration is. So if I double in the first order, if I double the concentration of A, the rate doubles. For second order, if I double the rate of A, it would be 4 times as fast. There are other orders that are higher than second order. We could have third, fourth, fifth order, and so on, but we won't go beyond second order for any individual concentration for an individual reactant. Okay, you can also actually have orders that are fractions instead of just whole numbers, but again, that kind of goes beyond the scope of our course. Overall order, normally you don't have just one reactant, you have several. So let's say we have theoretical reaction A and B, and the a and the little b represent the coefficients. The rate law for this one would be K, which is our rate constant, times A to the M times B to the N. M and N are orders, the reaction orders for A and B. The overall order of a reaction is the sum of the exponents for the reactants. So for instance, if I gave you this as the rate law for a particular reaction, with respect to the nitric oxide, which is NO, it's second order, and it's first order with respect to the hydrogen. If I want the overall order, I would add up 2 and 1, which were the exponents M and N, and it would be third order overall. So how do we determine order? The way we do this is using something known as the method of initial rates. And there's the bell. So the method of initial rates is basically looking at experimental data and identifying the value of K, M, and N by looking at different experiments where there are some things that are going to be held constant. Okay, so let's say I have this theoretical reaction here where we go back to what we had before, A, B, making products, and this is our rate law. Now the rate law is incomplete, but what we're going to do here is we're going to use this trial data here in the box to identify the value of M and N. We could also actually use it to identify K, but we're not going to do that for this one. Just M and N will be fine. So what we can do here is we can actually make ratios between the different pieces of data from our different trials. Okay, so what I'm going to do is I'm going to make a ratio between trials 1 and 2. So I take the initial rates and I'm going to set that equal to the rate laws. So that's what I did here. Okay, then what I do is I substitute in the concentration data for trials 1 and 2 into my ratio. Not only that, but also the initial rate data as well, which you see expressed in here and also here. Okay, so what we see here is that these are the two rates. It equals 1/2, right? And if I substitute in the values for the concentrations, notice how we have 0.1 to the end for both for the B portion. So this actually gets eliminated, right? Also K is the same for both since they're all happening at the same temperature, so the K gets eliminated too. So 1/2, which is what these numbers basically are, equals essentially 1/2 to the M. So this is how I identify the value of M. I can also do the same thing for trials 2 and 3, which is expressed here. So again, I substituted the values of A and B from trials 2 and 3 to make this ratio. Again, K cancels out. Also notice the A portion data cancels out, leaving me with this. I also take the initial rate data and I make a ratio with that corresponds. So 1/4 equals 1/2 to the N, and you can see here that N equals 2. So with respect to reactant A, the reaction is first order, and with respect to reaction B, the reaction is second order, and then the overall is third order. Okay, and we'll do some of these in class, and I'll try and help you guys out. But once you do, I think one or two yourself, you'll find it very easy. And until next time.